So let me start this video with a scam that I am sure that at least 80% of you have faced if you are a student of either mechanical engineering or civil engineering or maybe of aerospace engineering. I mean, if you have studied strength of materials, then you have faced this scam. There is a high chance of that. Okay. So now let me start. I will be asking a simple question to you, and that is if a beam, okay, is subjected to pure bending, okay, is subjected to pure bending, right? If a beam is subjected to pure bending, and I am not right now giving the boundary conditions, you have to just say that what will be the shape of the beam, I mean the deflected one, okay. So pure bending, and you have to answer the shape of deflection curve. Okay. So take your time. Okay. I think you have solved it. Now let me solve it. I think it is very easy. That is d2y dx2 is equal to m of x by ey, right? And here m of x is constant because it is a pure bending case, right? So that means my dy dx is equal to m by ei x plus c1, and my y is equal to mx square by 2ei plus c1x plus c2. That means clearly it is a parabola, right? Now, some of you will say that no, it will be a circle. But I will tell you that I have just solved it, right? We know this famous equation, and we are getting a parabola here, right? This shape. But if you are saying that it is a circle, then I can argue with you that I am just getting a parabola from a well-known equation. And if you are saying that that yes, this is correct, then my friend, you are wrong. So now in this situation, there will be three kinds of students. First, they knew that this formula is not correct, and they also know the actual formula, but due to having that bad habit of memorizing the formula and not going into the deep thing, you have already forgotten the thing. But now I have told you, I am just making you recall that what is the actual thing that I mean you should keep in your mind. You have memorized all these things, and now you know, but due to that bad habit, you have forgotten all that thing. The second kind of students will be that they will be like jumping out of the couch, and they will be saying that what, I knew that this is the formula, and obviously this should be the answer, that parabola. But now, but I mean, this guy is saying that I'm wrong. So how it is? And the third kind is that you don't know anything. You haven't studied strength of material, maybe because you are a first year student. So for all the three kinds of student, this video is a must. If you don't know anything, you are in a very good situation, because I will show you that how to learn the things from a point of view. If you want to become a scientist in Barc, ISRO, or DRDO, and if you already have known these things, okay, and you know the actual answer, that why this will not be a parabola and it will be a circle, and can you just mathematically prove it? If you can really prove it, then I should tell you that you should just purify your mental thinking, that you already know all these things, you have studied very well, but you should purify your thinking. Lastly, if you are in the zone, in the middle zone, that you know that I knew this formula is correct, but now this guy is saying that this is wrong. Or maybe you are confused that I have studied that during the pure bending, the shape will be circle, but yes, this is coming as parabola. I don't know why. Then, my friend, you are in the most dangerous zone, and I think that most of you are in that zone. So for you guys, this video is a must. I mean, I can't argue anymore that you should just watch this video. Okay? Because honestly, if you have something very wrong, to get out that from you, that is a very hectic task. And if you don't know anything, that is actually better than that. Now let me start. Don't worry, I will give the actual answer of this question. And this was not just a mere example. It is a question that was asked to me in BARC. So I will tell all those type of questions in this video. Okay, so not only interview questions. Other than that, you can expect from this video, firstly, the key assumptions behind the formula that is used. When we tell the sigma is equal to my by I, that is the smallest formula, very beautiful formula. Also, tau is equal to bq by ib, and this famous formula d2y dx2 is equal to m by ei. What are the key assumptions that you need to memorize? This I will tell. Then I will tell the real life interview questions from BARC, Bhabha Atomic Research Center, and those questions were asked to me. Don't worry, I will also make a detailed video on the interview experience of BARC. And finally, I have also scheduled for you that how to, obviously, how to study for those interviews. What should be your thinking about, when you are studying the strength of material and mainly these two topics, how you should think to develop that logical thinking during interview. And finally, okay, I will show you that not only interview, if you are someone who is okay with just cracking gate, कि मुझे तो बस gate crack करके PSU जाना है या फिर कोई IIT पे जाना है, then also I will show you that you should study like a particular way so that it can make your gate journey easier. Finally, I will give you some assignment problems, assignment questions. Fine. And again, I will just mention that this video is not for you. If you want that I will teach you full SOM in this video, or full strength or full shear force and bending moment in this video, no, I will not be doing that. I will show you that how to learn those things. What should be the actual mentality if you want to crack Barc, ISRO, DRDO, or maybe NPCIL, or maybe any kind of good IIT interview. Okay, what should be your mentality? And if you want some magic pill, or maybe some tricks and tips, very quick fix कि मेरा एक हफ्ते बाद इंटरव्यू है, मुझे बता दो, that is not possible. You have to build that mentality, and this series, this interview logic building series, is for that one. Clear? Okay, बहुत ज्ञान हो गया. Now let me start the things. So first, assumptions. So assumptions of these two formulae, because these two formulae are the most used formulae. I will show you that yes, in the BRC interview also they asked me from this formula. Okay, so let me just start. Firstly, sigma is equal to my by I. The first assumption is pure bending. Okay, pure bending. I think you already knew this. So these assumptions, I should suppose that you should have studied this. If you have studied from a good study material, it can be a lecture, it can be a book, then you should have known this. So pure bending means M is equal to a constant throughout the length of the bend. Then it should obey the Hooke's law. Okay, that is stress is proportional to strain, right? Or I should write E. So then the loading should pass, through the plane of symmetry, and the will be bending will be in plane of loading. Okay, and plane sections will remain plane after bending. Clear? Plane sections will remain plane after bending. And then Hooke's law is valid. I have already told this. And your Young's modulus during compression is equal to your Young's modulus during tension. So E tension is equal to E compression. I think I have done all the things. Okay. So these are mainly the things. Okay, these are mainly the assumptions. So if you want, you can take a screenshot. So I will just quickly explain all these things. That is, pure bending means m is a constant. So I will draw a beam here. Okay, maybe this is a beam, and maybe it is having this kind of supports and this kind of loading. So it is saying that throughout this length, okay, throughout this length, this m is a constant, and then Hooke's law is valid. That is, stress is proportional to strain, and then the loading should pass through the plane of symmetry. And what does this mean? So this means that if I have the 3D beam like this, 3D beam like this, then see, this plane is my plane of symmetry. This plane is my plane of symmetry, and the load is acting through this plane of symmetry. And in this plane only, the bend will be no, the beam will bend. Okay, what I was saying, the bend will beam. So the beam will bend in this plane or any other plane which is parallel to this, right? And now the plane section will remain plane after bending. So now what does this mean? So if I say that here I have a section which was plane before any kind of bending, so after bending also it will be like this. So if this is my bending plane, so it it will be something like this. Okay, the beam will be something like this, but at every section, if it was plane earlier, then it will be plane after the bending also. And E tension is equal to E compression. This is just an assumption. Okay, so now you have to keep in mind all these assumptions, because in BARC they can give you very, kind of conceptual question. They can ask you, okay, now if I am having a plastic deformation, then what will be the stress? And then you are applying the same thing, but it is not valid, because it is valid up to the limit at which this Hooke's law is valid. So you need to keep in mind these assumptions. Now there are two ways. The first approach is that after watching this video, you have taken the screenshot and you are just mugging up this thing. The next approach is you are going through the derivation if already you haven't gone through, or if you have already forgotten that, then you should go through the whole derivation again and again, okay, so that you can understand everything, and then you don't need to memorize these things will be automatically embedded into your brain. Okay, now for this thing also, all these assumptions are valid. Okay, because during the derivation of this formula we need this formula. That means all these assumptions are valid. So these are the same assumptions that we do require for this also. Okay, now let us go to this one. This is very interesting. Now I will answer to you that why that will be a circle. I will mathematically prove. For that, if you have already known the derivation, then I should tell you that this is equal to 1 by rho, where this rho is equal to actually radius of curvature of the beam. Radius of curvature of beam. Okay. So, okay. Now, can you tell me the mathematical formula of the radius of curvature of any curve? So, obviously, I mean, I would not suggest you to memorize this kind of formula, but now I have just noted down here the formula, and I am just copying that. Honestly, there is no glory on memorizing this kind of formula. Okay, the formula is this. That is this one. Okay, so this is the formula of 1 by rho. Now, honestly, this is not the fundamental equation. This is not the fundamental equation. Fundamental equation is this. After all those assumptions, fundamental equation is this. And if this is the fundamental equation, now don't ask me that how this is the fundamental equation, because honestly, I am not here teaching SM. I am just showing you that what should be your thinking. Okay, I mean, for those who have memorized this as your fundamental equation, so honestly, you need to change your mentality. At least, even if you don't, I mean, even if you cannot memorize the full derivation, that is perfectly fine. I will not suggest that. But you should understand that this is not the fundamental equation. The fundamental equation will correlate this m by ei with 1 by rho. That is the radius of curvature. And how it can correlate that? For that, you have to go through the detailed derivation. Okay. Now, if you go through the detailed derivation, understand there are many fold benefits. First of all, you will crack the interviews. Second, you will crack the semester examinations, because semester examinations, some kind of derivation can come. Thirdly, you don't have to memorize the assumptions. And fourthly, you are ready for the interview. Okay, because if you can build the logic step by step, the logic for derivation, then you are ready for interview, and that is a very good thing. Okay, now if this is 1 by rho, that means this should be equal to m by ei. So this is the actual formula. Okay, this is the actual formula, right? But now, then actually, I'm sorry, this is actually rho. So this is actually rho, the radius of curvature. I'm sorry, this is actually rho. So that means if it is rho, then this will be ei by m. Extremely sorry for this. Okay. Now, if this is the actual formula, now then how can we get that m by ei is equal to this? So इस पूरे term का I mean क्या हुआ? So the thing is that consider that this is the beam. Okay, this is the undeformed beam, and I will show it through a dotted line. Undeformed beam here, and this is the deformed shape. Now at any x, so if this is the x direction, at any x, this is the tangent, then this is the slope theta. So tan theta, this will be dy dx. Okay. Now in this formula, if we say that the slope is very small, then my dy dx is much less than 1. Then I can say that my 1 by, I mean that my 1 plus dy dx whole square, sorry, this one is almost equal to 1, and that means this term I have proved that if my slope is small, or in other words, the beam is almost plane, that is, it has a very small deflection, then only I can say that this is equal to 1. And then I get the formula that m by ey is equal to this one. Now, in the actual derivation, they will tell you this I mean assumption, this assumption. They will actually tell you. Now, in that case, people have studied that, but still they are not understanding that why this formula is not valid. Okay, they have studied that the slope is very less. They have marked up the assumptions, but still they will not be able to tell that why this formula we are not uh, using. Why? Because they have only memorized the assumptions that, okay, I know that my slope is very small, but I don't know that slope is actually dy dx. So you have memorized it, you have not understood it. That slope is my dy dx. You don't know that slope is dy dx, and that is very small. You know slope is small. I mean, you haven't understand anything, but you are just mugging up the assumptions. You have to get out from this kind of mentality, honestly. So now here, okay. Now, if I have to prove that this is a circle, then I need to solve this equation. So let me just quickly solve it. So m by ey is equal to this whole equation, that is my d2y dx2, okay, d2y dx2, right, by 1 by dy dx whole square, okay. And for pure bending, this is a, constant, okay. Obviously, the assumptions are that my m by e, pure bending, m is already a constant, and ey, I am assuming that ei is a constant. So then this is a constant. So if this is a constant, now I say that my dy dx is equal to a. That means my equation will be this, right? 1 plus a square 3 by 2 is equal to c. That means if I do the integration, I have to do this one, c dx, integrate, right? So now how can I integrate this? Take a is equal to tan theta. That means my dA will be sec square theta d theta. That means my integration will be sec square theta d theta by 1 plus tan square theta, that is sec square theta, and into 3 by 2. So that will be sec cube theta, okay, sec cube theta, and that is equal to cx. And now this will be what? Cos theta d theta, that is equal to actually minus sin theta, and that is equal to cx, right? Now, how can I get my tan theta? Because tan theta is equal to my dy dx, right? And that is equal to a, right? So I got that, sorry. Yes, a is equal to tan theta. Yes, right. Here I have taken that assumption. So I am just doing it very much quickly because I just want you to show that it is actually circle. I've actually never seen anyone to show it like this, that this will be actually circle, not theoretically but also mathematically. Okay, so this is a very important concept. So tan theta is equal to a, that I know that sin theta is equal to minus cx. So that means my cos theta from this equation, that will be 1 minus c square x square. Okay, that means my tan theta is equal to sin theta by cos theta, and that will be equal to minus cx, that is my sin theta, and cos theta is 1 minus cx whole square, and that is equal to my a, and a is equal to dy dx. I have already defined that here clearly. So now from this equation, now it is actually very easy to solve. Okay, so minus c integration of x dx, and if I take a 2 common here, 2x dx minus 1 minus c square x square is equal to my integration of dy. Clear? And this will be minus c by 2. Now you see I can write this as my d of x square. So this will be directly 1 minus c square x square whole to the power minus of plus 1, that is this, and by 1, right? Okay, so this will be my y. Okay, and one more thing, there will be a division by minus of c, actually minus of minus of c square, sorry, minus of c square. If I do the integration correctly, there will be a division by minus of c square. So minus minus will be cancelled out, right? And finally, this half of will be cancelled out. So 1 minus c square x square is equal to c square y square, right? So you see, I am getting x square plus y square is equal to 1 by c square. And what was my c? C was my m by ei. So that will be here ey by m whole square. So this is the actual beam deflection, equation for a for a pure bending case. Now, ideally, you should have done everything like this with this formula, ideally. But we are engineers. We are here to make things simple, to simplify things. That is why we have taken this, assumption. We have taken this assumption. Okay. Okay. Now, I think the most interesting interview question. Okay. So now, one more thing. This is the radius of the circle. So if the beam is, the beam is maybe, it is, the beam is just bending like this, then the radius will be this EI by M. Okay. So now maybe the most interesting part, that is the real interview questions. Okay. So here, firstly, I will go through it very quickly. It was a very interesting question that you can have a bending moment diagram like this, that if this is X and if this is Y, then you can have, I am just drawing arbitrarily, you can have a bending moment diagram like this, and after this. Okay. So this is a dotted line. Okay. So now they will ask you, okay, so at this point, uh, I mean, at this point, what is the value of this M, this bending moment? So now you have already studied that, okay, I know that this is my bending moment diagram. I have studied that how to draw a bending moment diagram. But so I have, this particular question was not asked by me. I got this question from Quora. Now that guy answered that, that guy actually first answered that, yes sir, at this point, this or this can be the answer. So this is totally wrong. And do you know the answer? The answer is that if this is point A, then for x tends to A minus, maybe this is the value M1 and maybe this is the value M2. For x tends to A minus, I will take M is equal to M1, and if x tends to A plus, I will take M is equal to M2. So at this point, you have to tell that this is the answer. It will be answered mathematically by the concept of limit. Okay, so you have to study like this. Why? At the same point, I am having two moments. Because the ideal thing when you are writing the bending moment equation, you should have written this thing, that when I am approaching this point A from this direction, I am getting M is equal to M1. And when I am approaching the point from this direction, I am getting M is equal to M2. So these are just some examples that, these are the examples showing that where the, interviewers can make you uncomfortable. Okay. Next question. Okay. Now this question I was asked, that if I have a cantilever beam and if I apply the moment here, then can you first draw the nature of the deflection curve? The nature of the deflection curve. Now I will ask you to draw it by just pausing the video. I know that some of you will draw something like this. Okay. I mean, yes, it is a long, so some of you will draw something like this. And here, the major mistake is that you are drawing a finite slope here. So it is a very common question in BARC that they will ask you to draw the nature of the deflection curve. When they are saying the nature, you have to maintain the slopes very carefully. The slopes. Okay. So this is a fixed connection. That means here the slope should be 0 by definition. So the answer will be something like this: 0 slope, and then it is increasing. Now they ask me that, can you tell me that what will be the shape of, sorry, what will be the equation of this, uh, uh, either a parabola or a circle? So this was the same question that I asked you just now, right? So I got the answer that it was circle, that it will be circle, because I knew that there is a particular assumption, and I also knew that this Ey by m, this actually will be rho, and this will be that actual formula, and that is why it will be circle. I actually knew it. And even if you don't know it, by the basic notion that it is a case of pure bending, everywhere the bending moment is constant, so you are supposed to draw a circle, because you know that if it is pure bending, then it will be a circle. Okay, there is there is one more catch. Actually, you cannot apply a particular fixed support and the moment at the same time, because these two are the boundary condition. So when you are saying that it is a fixed support, then here this delta will be 0, that is the deflection. And when you are giving the moment, then you are describing a moment. So these things are, so this moment is not 0, is having some value, maybe m1. So these things are boundary condition, and at any particular point you cannot prescribe two boundary conditions, because you see you have a second order differential equation here. So then you need to have two boundary conditions at two ends. Okay, so these are the subtle concepts that you have to tell them. Then I cannot apply the moment exactly here. I can apply maybe at a point that is just outside this point. That is true. Okay. Okay. Another question they asked me, they gave me a situation. Okay, like this maybe. I don't, I mean, I don't memorize these things generally. So they gave me these kind of things, and they told me to draw the shear force diagram and bending moment diagram and the, deflection curve, the nature of the curve. They told me to draw it. Okay. So all these things were there. So this thing is very important, that you should be able to draw the nature of the curve. Okay, not by solving the equation. So for this equation also, so for this case also, if you draw something like this, it is wrong, because here you have drawn a finite slope. Firstly, this will be a zero slope. Then it will maybe something like this. Then you have to think then that either it will go up or not. So how can you think that? The best answer is that if you have the bending moment diagram like this M and X, then by the moment area method, the slope of the curve is proportional to the area under the bending moment diagram, that is Mx by EI. So this is the moment area method to find the slope, right? So if you see that the area under the curve, if it is something like this, maybe the bending moment diagram, you see the area is increasing with x. That means the slope will also increase. That means it cannot come up. Although the load is here at this point upwards, it cannot come up. It has to go down. Okay, because the moment, the area under the bending moment diagram is actually increasing. See, you are applying this formula here, or the just a simple concept that the slope is actually proportional to the area under the bending moment diagram. So you should have this kind of logical thinking. Okay. Now, fourthly, I think I have actually noted down all the questions here. So, okay, 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 finally, the last question, that we say that we will apply the formula sigma is equal to m by m by I into y for pure bending, right? We say that this is valid if we take this assumption, but we apply also we apply this formula when this m is a function of x, and maybe it is not a constant. So this is a good type of contradiction, that we say that we are deriving this one having in mind that it is valid for only pure bending, but we are applying this formula for a case when the bending moment is not constant. So where is the catch? The catch is that if I don't have the bending moments as a constant, then there will be additional shear forces, but the stresses developed due to those shear forces are very small, compared to this sigma is equal to my by I. That's why we do neglect those forces. These concepts are very important. This is the actual reason. Obviously, this cannot be proved mathematically. This can be proved. You have to find those shear stresses, and you can show that that value is much lesser than this value. But this is actually can be found more accurately from an experiment. But you have to know this particular, uh, I mean, this kind of things. Okay. Now, see, this should be your thought of train. Thought of train? Sorry, train of thoughts. Okay. So this should be your uh, train of thoughts, that you should be having this particular question in your mind while studying, that yes, in the assumptions, he is saying that this is valid when m is constant, but when I am doing the a particular gate level PYQs, I am seeing that the m is not constant, but still this is applying. Why? So if you are developing this type of curiosity and these types of what and why type of questions, then you are in the right direction towards Barc, ISRO and DRDO. So finally, let me make your gate easier. Firstly, I should tell you that in the machine design subject, the application of this shear force and bending moment is very high. So in which chapter? Firstly, shafts, design of shafts. So design of shafts is made of this shear force bending moment plus theories of failure. Okay. Plus maybe I have actually noted it down. Okay. Plus obviously torsion. Now this torsion is also very important. Okay. But you see that this is actually 40%, this is actually 40%, and this theory of failure, this is actually so 40, 40 and 20. Okay. So and you see that all these three things you have to study in strength of materials. So if you study these three things in strength of materials, then this subject in the machine design, this topic is already done. Be it a static loading or be it a dynamic failure type thing, or a kind of fluctuating loading. For both of the things, you have to first find the bending stresses or the shear stresses. Then only you can do the further steps. Then springs. There is a in spur gear we have a formula where they have considered this teeth of a spur gear like a cantilever beam, and they have used this like piece of a load. Okay. And third, so all those things are there. Right now, I don't just, recall all the things. But what I'm trying to say is that don't see like, okay, machine design is different and strength of material is different. No, strength of material is the core on which machine design is standing. Okay. So you cannot study strength of materials, sorry, you cannot study machine design if you have not covered strength of materials well. Okay. And and you can make your journey easier by finding these kind of intersections between the topics of two different subjects. Okay. Now, finally, one very important skill for every, engineer, that is very much important, that is visualization. Visualization. So, this means that if I have a beam like this, I have seen many students that they cannot show the direction of bending stress and shear stress. Okay, you should have the visualization. I am just bending the beam something like this. Okay, then this fiber, this fiber will be stretched. It will be something like this after the deformation, and this fiber will be compressed. So if this fiber is stretching, then the stress on this fiber, uh, I mean at this point, the stress will be in this direction, and at this point the stress will be in this direction, a compressive force. And we draw the stresses for this beam only, and we show that the bending stresses are either of this or this. Like, so it is like a tensile loading. We call it a bending stress. We call it a bending stress, but it is having a direction like a, a tensile loading type thing. So you should develop this kind of visualization. This is very important, and this is more important for the machine design subject, because there, if you have to draw the Mohr circle, or if you have to find the principal stresses, then they will say you that okay, take an element like this, and for this element draw the stress state. That means you have to tell them, okay, here I will have this type of compression and this type of shear stress, this type of shear stress. And how can you draw this if you don't know that how the bending stress actually act? What is the direction? And again, don't memorize these things are not to be memorized. These things have to be understood by intuition. Okay, so I am just asking you because in BARC they told me, can you draw the stress distribution for this beam? For this beam, can you draw the stress distribution? So if I just extrapolate this, the stress distribution will be something like this, right? And we all know this, right? And they were saying that okay, then you just tell us that is this tensile or is this tensile? So I told them, sir, this will be tensile. And then they told me why. So I answered them by intuition, sir, because if I see the type of bending here, it will bend something like this. So this part will be stretched, and that is why this will be tensile. They were very satisfied. So this type of visualization should be there. Okay. So I think I have covered everything. After that, you will be getting 2 assignment questions, the solutions of which I will be posting within 1 week after this publication of this video. Now, this video was so long. I am also tired, and I think you are also bored, right? But I always try to, I always try to, post these things, that this should be the actual approach. We always think that okay, I will just memorize the formula. I just I just have to get the uh, I I mean I just have to get the gate level questions to be solved. Everything is okay, but if you want to crack Barc, ISRO, DRDO, and any IIT or IISc, you have to study like this. And moreover, please understand that studying like this will make your gate journey easier, because if you go through the things, the derivations like this, you have to memorize less. And if you think that I will not go through the derivation because they are boring, then you have to memorize more. Now the choice is yours. In one hand, you can memorize the thing, you can be ready for the interview, for the semester. On the other hand, you have to do all these things separately. For semester examination, you have to memorize the full answer. For gate examination, you have to memorize the formula. For interview, you are searching here and there the for the past year interview questions. So these things will not, work like that. And I have also made I have also made a same kind of video on Navier-Stokes equation. Okay. So, and also this will be a full playlist of interview logic building series. I will take the most important type of concepts which are not only important for interviews but also important for gate examination. So, you should go to those videos and that playlist. I will meet you there. Until that, goodbye, take care, and thank you.